Today we are starting a special one-week program on geospatial inputs for enabling master plan formulation under AMRUT sub-scheme. We have got IIRS is conducting several programs with the wide-ranging topics. This program is also unique in the sense this is focusing towards geospatial applications in one of the flagship mission programs of Government of India, that is AMRUT. And under the AMRUT, we are highlighting the applications of geospatial technology in its sub-scheme. That is the under the AMRUT program, the fourth reform, where the large usage is there of the geospatial technology for the master plan formulation. And now, in this particular lecture of today, I'm going to deliberate on how the geospatial data can be used for enabling the master plan formulation. Okay. Now, I'll take on some of the fundamentals. While I start with this lecture, I'll take on some of the fundamentals and the components of geospatial technology and how this is being used in a one operational program of Government of India. I'll also deal about what are the different steps in database creation under the AMRUT. While doing so, already the Ministry of Housing and Urban Affairs, Government of India, has brought out one very important document, that is design standards for creating the database. So what I'll do in this 1 hour session, that I'll try to link the technology and its applications and fundamentals, that how it can be used in this particular program. And then while I'm doing so, I'll also take on some of the fundamentals. Then I'll take about what are different steps in the database creation, ranging from GCP's collection to the image handling and to the information extraction. Later on, then I'll deliberate on the how the database information can be extracted, and then what are the different steps and the methodology prescribed for quality check. Okay, and then AMRUT has got important emphasis on utilities and then facilities creation within the urban areas. So how the technology, geospatial technology, can be used in this sector, that also I'll deliberate upon. And then, because along with the MOHUA and its wing, that is Town and Country Planning Organization, we have developed the course contents for training and capacity building of the urban planners across the country. So I'll deliberate upon the some of the contents that has been developed, and that how that is enabling the urban local bodies for plans preparation. Now let me begin with. So when I'm doing so, let me take on in a single slide about the geospatial technology. I understand some of you might have undergone some of the basic or advanced courses of IIRS, and there are plenty of material available on the internet platform. And otherwise, if you are the program partner of the IIRS, you are already aware of the some of these technologies. I'll just take on in single slide what the geospatial technology is, which is nothing but the process technology for collection, storage, processing, and dissemination of geographic or spatially reference information, which encompasses several techniques like remote sensing, photogrammetry, global navigation satellite system, that's GNSS, or in a common parlance we call it as GPS, the field sensors, survey instruments, and then all this information are later have to be taken on to the GIS. Okay, and as such, because the information dissemination has to go on, that's how its convergence with the ICT tools has to happen. We are aware about the remote sensing, which is nothing but the art science of obtaining information about an object without being in contact with it. We've got plenty of sensors which are in the orbit, okay, which are going around the earth and acquiring the remote sensing data, which have got wide-ranging characteristics, ranging from resolution to the electromagnetic characteristics to the usage for it is meant for. Then, because in the traditional manner, we have been acquiring the information about the surface using the photogrammetry techniques, which is nothing but the art science of obtaining information using the aerial photographs. In the modern times, the emphasis has gone on digital photogrammetry or the close range photogrammetry. Then we have got the GNSS, which is nothing but an array of satellites which helps us to find out the location of any object on the earth. Okay, and this is also useful to geo-correct the remote sensing images, and also to precisely collect the information about various objects, because the remote sensing data has got found, I mean, it has found wide usage, but even then there are several information which have to be collected from the ground. That's how the field sensors have got their importance. These are field sensors, and if they are mounted with the GPS, then the information what they collect, that can also be brought into the GIS domain. Okay, and then as I said, the GIS has got very important role for data collection, storage, retrieval, and manipulation and analysis. Okay. Let me go on further, and then while I'm doing so, as I said, I'll try to link it across different components of the AMRUT subscheme, how the technology is being used. In a single slide, I'll try to deliberate upon some of the fundamental and the processes involved in the remote sensing. As such, the sensor could be passive or active. Okay, but in general, in the in the AMRUT subscheme, we are largely dependent on the passive sensors. Okay, because of the need which can be fulfilled. I mean, the passive sensors, they are good enough. So the passive sensors, they receive the energy which is reflected up from the Earth's surface, and the source of energy is the sun, and then the energy which was emanated from the sun, mighty sun, goes to the atmosphere, and from the atmosphere it hits the surface, and the reflected energy again processed through the atmosphere, and based on the material and the energy interaction, the signatures, I mean, the reflected energy is recorded by the satellites. Okay. Now, then once the data is collected by the satellites, it is disseminated with the specialized channels to the ground receiving station, and the ground receiving station, the data which is received after the pre-processing operation, it is disseminated to the user. Once it comes to the user, then the user has to take on for the interpretation and analysis, and the product is generated. So as such, in the AMRUT program, our involvement starts once the data is received by the interpreter, and then he interprets or analyzes the data, and the information dissemination has to happen. As such, we should be aware about the spectral reflectance curve, because as I said, there is energy and matter interaction. This energy and matter interaction happens because of the incoming solar radiation, because we are particularly I mean, in the AMRUT sub-scheme, we are using the sensors which are working in the passive domain. Okay, so as such, if you take it in the I mean, within the urban areas, primarily they are built-up surfaces. Then there are vacant spaces. There are natural surfaces. So as such, if you put it together, then they are basically can be taken in three categories. First is the built-up, that is the concrete or other material, or built-up material. Then there will be the other material, I mean, areas which are covered with varying intensity of vegetation. And then there will be some other characteristics, land cover may be present, like the water bodies, etc. So as such, let us take on some of the fundamental material which is present within the urban areas, the concrete and allied surfaces, and then the vegetated areas in different intensity of vegetation, and the water bodies. If you take these three basic material which is present within the urban areas. If you take it, and as you are already aware, if you take the spectral region, then there is a sharp spurt which is increasing in the near infrared region. Then there is some absorptions are there, and then finally the spectral characteristics varies across the different spectral domain. This also happens in the case of the concrete and the other built up surfaces. In general, the reflectance is quite high, except in the infrared region, where because of the certain properties of the leaf material and because of the cell structure, the reflectance is higher as compared to the concrete surface. And then in general, the reflectance is higher for the concrete or the built up surfaces. As such, when you take on the water bodies, because the water bodies appear blue, that means the reflectance is higher. But as we move towards the relatively higher wavelength region, the reflectance decreases. That's how the water bodies, they appear darker. So this is the very important curve which controls the manifestation of different material which is present within the urban areas. And once someone has understood that this all reflectance characteristics, that's how one is able to interpret the features. So there are some other important factors which govern the reflectance from the urban areas. That is, if it is the vegetated surface, then because of the leaf pigmentation within the areas lower than the infrared region, and within the middle infrared or the infrared near infrared region, because of the cell structure, and in the later part of the infrared region, because of the water content, the absorption happens. Okay, so these all properties, they govern the reflectance from the surface and within the urban areas. So once the bands or the acquired data comes to the user, what he can do, he can use any image terminal, and then the input bands, they are displayed in conjugation on the screen. Okay, so what happens that the lookup table is applied for each band, and then finally a composite image is generated, that we all know it, that is called as false color composite. We are all aware the definition of the image, that is, image is nothing but a two-dimensional array of pixels, or which is nothing but the picture elements. So let us see. I mean, I am not aware about the knowledge level of you, the participants who are attending this program. But let me take on very fundamental aspect, that how the false color composite is generated. The false color composite is generated, as I said, which is the combination of three bands. And in general, the standard false color composite is prepared based on the generating a composite of green, red, and near infrared. Okay, so what happens when you are generating the false color composite? Because of the, as we have seen in the reflectance curve, that the vegetation is relatively, if we go back again, the vegetation is slightly higher, reflectance is slightly higher as compared to blue. But still the concrete surfaces, concrete and allied surfaces, they are still brighter. So what happens, if you look at the false color composite and its constituent band green, if you take it, the vegetation is relatively darker, and the built-up surfaces, they are much brighter. If you go to the red band, what will happen? Because of the absorption within the red band, the reflectance goes slightly lower for the vegetation, and the concrete surface, as usual, they are brighter. But if you go to the infrared, what happens? That because of the several properties of the vegetated surface, the vegetation areas, they appear lit much brighter as compared to the concrete surface. As you see that the thousands of LEDs, but they are lit together. That's how the vegetated surface, they appear much brighter. Now you see that because each band has unique properties, and they signify some significant property of the vegetated surface. So each individual band has certain property. If you combine all these properties together, that's how the false color composite is generated, and then it consists of a treasure of information which is individually reflected by each constituent band. So why do we do so? Because the a composite of three bands, they contain the information which are primarily demonstrated by the individual band, and it has got its inherent characteristics. Again, the question will come: why do we used to seeing the false color composite? For the reason being that the images, and particularly the red color, is formed closer to the retina, and we are able to interpret the features, particularly they are in the red color as compared to the other regions of the color cube. Okay, so if you take this one, then how you can see within the visited surface there are tree cover, okay, and there are grass cover and other characteristics of vegetation. Within the tree cover, you can see the variety of vegetated surface which are different because of the various phenological stages and because of the various management practices, which may be because of their different species and other characteristics. That's how the information content, they are put together in the false color composite. They are much easier to interpret, and you can see here. But the question comes that because a common man, no, will always ask why the vegetation is appear green, because it is good to interpret, but a common man will always ask for the natural color. That's how we are generating by the color transformation, where we subject each individual band to a certain combination of the mathematical composite. We make it and we generate the natural color composite. But there will be always a trade-off between the false color composite and the natural color composite, because though we are seeing the features as they appear on the ground, but their interpretation quality will go slightly inferior. If I point out, for example, here, there's a vacant space here. You can see some distinct patches which are appearing. But if I go back to the false color composite, they will appear much easier to interpret as compared to the natural color composite. It's the same way, you can, if you toggle around different parts of the image, you can see different features which are much easier to interpret on the false color composite as compared to the natural color composite. Again, if you move on further, because the digital data, because the decades ago, 2 decades ago, when the remote sensing technology was its infancy stage, the emphasis was largely on the visual image interpretation, where we use the skilled interpreter who used to used to extract the information using the visual interpretation techniques, where the images, hard copy images, were put on the light table, etc. But in the recent times, digital technology has found wide usage, and once it comes in the digital form, we can do several kind of manipulation using the technique. For example, if you see here that because of the solar elevation angle and so other features, there is something called false topography phenomena, where the buildings are appearing inverted. So what we can do, we can easily rotate the image by 180-degree, and you can see here that the buildings are appearing as if they are on the surface rather than appearing embossed within the surface. And the tree cover is also appearing the way they are supposed to be. That's how the topographic inversion correction is done, and this is much easier to interpret. But also there are other characteristics that can be enhanced using the various image or based operations, that is called digital image processing. One such operation is the edge enhancement. What we can do, if we apply certain filter, then we can easily distinguish or separate out the building footprints, and the objects, they become much superior or easier to interpret as compared to the raw image. But keep in mind that all these image based operation, they alter the pixel value. There's a digital number, so there might be some trade-off when you want to digitally classify the image. But this is good to visually interpret the image. When you are doing so, then you can enhance the image, because within the AMRUT, the emphasis is on largely on visual image interpretation. That's how, if you got the digital data which is emphasized within the AMRUT, then what you can do, various image-based operations on the screen to enhance the image. Okay. Now let us take on further that each image has got inherent characteristic, that is the resolution. I'll speak about the resolution in the subsequent slide. But the importance of resolution is, if you're displaying it is a certain image of one urban area, if you look at the image has been enhanced on the screen, magnified on the screen to a scale of 1:1000. Now you see the pixels have started to breaking because of the inherent characteristics of the image. That means image is telling us that it is not feasible, it is not advisable to magnify this image at the scale of 1:1000. So what should we do? We have to magnify the image to a scale, or display the image to a scale which is in consonance with the sensor resolution. Okay, so the resolution is very important term, that when I'm displaying the image, I'm trying to emphasize that the resolution plays very important role. Okay, so the 1:2500 is much better scale to visualize this kind of image. Or 1:5000 is also good scale, where the much larger view is seen. But you may ask me a question, what is the appropriate scale to see the data on the screen? So that question has to be answered. So what we have to do when we are displaying the image on the screen, then we have to apply certain resampling method. That resampling method is nothing but the arrangement of the pattern of image, how they are displayed on the screen. Typically, there are several methods like nearest neighborhood, bilinear interpolation, or the cubic convolution. They are very popular methods which are used for displaying the image, and then resampling methods which are being used. Okay, so the resampling method, when you are using the nearest neighborhood, is very popular, and it is does not alters the pixel value. What it does, just picks up the nearest pixel and then displays on the screen. Now I'll also emphasize here that this resampling methods, they also play very important role when they are once the data is geo-corrected or rectified. So I'm using the certain term called, those who are newer to the technology, the resampling method I have used, and then I have used the image rectification. These all questions I have to answer within this 1 hour session, and then I have to link it with the AMRUT sub-scheme. So as I'm telling, this nearest neighborhood method, this is very important, but when you are doing so, it has got certain disadvantage as well. The building footprint, for example, they will not be appearing sharper. If I'm using the cubic convolution, if I zoom certain part of the image, you may see the building footprints, they have got superior as compared to the, if I'm using the nearest neighborhood, though it has got some merit and demerit. So the summary is, the nearest neighborhood method can be used when you are subsequently deploying the digital technique, because it does not alter the pixel value, but one can use the cubic convolution if someone is using the visual image interpretation techniques on the screen. But as I said, that within the AMRUT sub-scheme, we are trying to extract the information on the screen by visual interpretation technique. So the cubic convolution is a prescribed method for the AMRUT sub-scheme. Now, let us take on with this very fundamental aspect of the remote sensing for data acquisition and then on display, etc. So let us take on some fundamental aspect of AMRUT sub-scheme. AMRUT is Atal Mission for Rejuvenation and Urban Transformation. You might be aware that recently the government of India has announced the AMRUT 2.0, and that reflects the emphasis which has given by our government on this particular sub-scheme. The AMRUT sub-scheme, it mandates a set of 11 reforms which are supposed to be implemented for 500 mission cities under the initial mission. And the first area under the AMRUT sub-scheme is on the water supply, sewerage facility, then improving the urban mobility, and then ultimately enhancing the amenity value of cities by creating and upgrading the green spaces, recreation centers, etc. That's how the focus of the thrust of AMRUT scheme. Within the AMRUT program, there are total uh, 12 reforms are there. Okay, basically 11 plus 1. And then within this reform, under the fourth reform, where this sub scheme, where this lecture or this 1 hour, 1 week training program is focusing on, there the large usage of geospatial technology has been emphasized. Now, this under the fourth reform and for the master plan formulation, it has been advised based on the document which is available on the internet, and you can browse through within the internet and within the MOHUA Government of India website, that is the design standard document, which prescribes that the database at 1:4,000 scale has to be prepared for master plan formulation. And then as per because the master plan is a subject which has to be governed by the Town and Country Planning Acts, and this has to be generated on the GIS platform. And as I said, that the capacity building is a very important component, and that's how when I am at the end of this 1 hour deliberation, I'll also discuss about how the capacity building component has been addressed within this program. Now, as such, the importance of this program is, though as per the 2011 census, we got 7,935 towns, and at that time we have got only 15% of towns at that time which have got the master plan prepared. And because in the absence of master plan, the growth is not regulated. That's how, because under such scenario, there is linked processes which are there within the urban areas in order to improve ultimately the quality of life of urban dwellers. The master plan has got very important role to play. That's how the master plan formulation exercise is undergoing under the fourth reform, and then that's how the beautiful documents they have been placed and they have been developed by the MOHUA, and the capacity building has been developed by the IIRS and TCPO jointly. Okay, so let us take on further that's what are the different components within this fourth reform and for the master plan formulation. That is, first is using the high resolution satellite data, and then after the georeferencing, if you kindly recall, I emphasize the georeferencing or data rectification. Then after the data rectification, one has to generate the ortho-rectified satellite data. So what is this ortho-rectified satellite data? That is nothing but correcting the satellite data, every pixel on the satellite data in three-dimensional domain. And then first this kind of geo-corrected data is generated, and then we have to extract the information within the GIS platform, and then we have to combine a data sets which are collected from the ground from varied sources, and finally GIS database has to be prepared for, and then this is being supplied to the urban local bodies for master plan formulation. These were the steps which are being prescribed under the AMRUT scheme. Now the document, design standard documents say several standards for the remote sensing images in terms of resolution, that is spatial, spectral, radiometry. Then it also speaks about kind of satellite data. Should it be monoscopic? That means any area depicted on a single satellite image, or a combination of satellite image that is stereoscopic, that will be helpful to derive the three-dimensional information. That means if the slope of the area, if the urban areas are not undulating, then monoscopic satellite data can be used. If the urban areas are undulating, that means slope more than 15 degree, then the stereoscopic satellite data has to be used. Then the document further illustrates what kind of product has to be generated, that is geotiff file has to be generated. So this is the part of remote sensing data acquisition and image standards. Then if you go on further, then we have to understand the different kind of why we are procuring the satellite data, what kind of features should we keep in mind, that is resolution, bands, data pass, scale, what kind of band combination should we make, how the data information extraction has to happen, and finally we have to take the data, all the extracted information to the GIS, and the change detection has to be happen. So I'm putting a summary, the kind of question one may ask when the satellite data for AMRUT sub-scheme has to be procured. So because in our country the satellite data as of now is resolved by a sensor. Okay, so that defines the pixel size. Okay, as if you look at earlier, previously we talked about the spatial resolution as defined within the sub scheme, that is 0.5 meter or better. So what is spatial resolution and what is the standard which has been prescribed by the under the sub scheme, that is defined here. Okay, then comes the spectral resolution, because we have to generate the false color composite. That means the minimum three bands are required. So the bands should fall in which spectral range, that also has to be taken care of. Typically they are green, red or infrared to form the standard false color composite. Now within the AMRUT sub scheme, it is also defined that a data of single date that can be used for information extraction, but there are provisions, no, because the following the implementation of master plan, there is certain likelihood in some part of the urban areas within the proposed master plan, there might be a need that there are some aberrations which have come up, and in order to again look back into the current urban sprawl, then the newer satellite data will be required. That's how the temporal resolution is also important. That means revisiting the same area and acquiring the fresh image so that one can see the features 5 or later years back and the current. That's how one can see the temporal change. Okay, now the fourth characteristic is the radiometric resolution, and then the radiometric resolution is also very, very important. It helps us to distinguish the features. So that's how the resolution plays the important role. Now in the subsequent slide we'll try to understand the various kind of resolution characteristics in detail. In general, the spatial resolution, broadly it is put into three categories: high, medium, and low. Then variety of satellites currently they are in orbit, but in the AMRUT sub scheme, the thrust is on the high spatial resolution, and particularly on the very high spatial resolution, as you're seeing the resolution which is prescribed within the AMRUT sub scheme, that is 0.5 meter or better, which falls under the very high spatial resolution. Now, the ISRO has launched variety of satellites ranging from ResourceSat, Cartosat, and RISAT kind of series, which have got relevance within the urban planning. Okay, because they are relatively higher spatial resolution. They have also got the micro sensing characteristic. That's how they have got relevance in the urban planning. If you take into the regional planning, then there are other set of satellites that can be used in the times to come. No, because there is a need to have the much finer spatial or spectral resolution. In the times to come, we are going to have plethora of satellite for which will be launched by the ISRO or the other agencies in the world. And these will be HRSat, NICER, GISAT, and the upcoming sensors within the ResourceSat series or the RISAT, etc., which will be able to sense the Earth surface, urban areas. There will be much finer spatial resolution, better than 25 centimeter or superior, which will have the constellation of satellites, which will be evolving around the Earth in much lower orbit, and they will be much easier to launch or at a lower cost. That's how the satellites they are being, particularly the within the space technology, the thrust is going on elsewhere in the world. Okay. So if you take the variety of satellites which have been launched by the ISRO, ranging from very coarser resolution and the way the resolution, spatial resolution, these 360 meter or lower than the recently launched satellite in the November 2019. We have got the Cartosat 3 satellite, which has been launched, which has got the resolution of nearly 25 centimeter. Okay, that's how the range of satellites are available on the surface. And when you talk about the urban planning, there's always a quest for higher spatial resolution, where we are able to see the individual building and then the allied surface. Okay. Then, as I said, there are variety of satellites which are there, which have been launched maybe nearly 2 decades ago. The recent times, variety satellites are available from the ISRO from the Cartosat 3 series or other satellite series in the world, ranging from Worldview to the Spot, ComSat, etc., and the plates and so, which have got relevance in the urban planning. Okay. Now, if you take the second aspect, that is the temporal resolution, then benefit of temporal resolution is this is a kind of urban area in a certain city. When you're seeing here, you can see the changes which have happened within city because of various factors. That's how the sprawl has happened. Now, this kind of sprawl, that is much easier to detect using the satellite remote sensing rather than hearsay, which are collected from the various other methods. That's how the temporal satellite, temporal resolution has got important role. Let's take another example where, because of the government intervention, that haphazard or other pattern along the river, in the Sabarmati, where the land utilization is much poor. That's how, because of the government intervention, the river, either side of the river has been trained, and this has helped us to create the recreation space and also the giving the impetus to the economic activity. Okay, that's how the temporal resolution, if you have got before and after image, you can generate and see how the changes they are happening on the urban area. Take another example where the urban development is happening in certain part of the Mumbai area. That's how the single story buildings in the very dense and congested area, they have been because of the intervention, government intervention, and also the society participation that is happening. And that's how with better FAR utilization, that's how the taller structures they are coming up, and with the vacant spaces in the ground, which are not crowded and easier to commute. That's how these surfaces they are coming up in other parts. And that is, if we are able to capture, is on the left hand side you are seeing the present and past, and then on the right hand side you are seeing the satellite images which are nearly 2 decades ago and the recent time. So As such, when the data is acquired, then the question will come about the image quality, georeferencing, image enhancement, and image classification. So all these aspects, when you take on, no, the question is the satellite data based on spectral radiometric characteristics. No, there will be digital number. This kind of digital number based on this contrast or the other statistical properties, one has to look on that. If you look at this a plot of the frequency versus the digital number, if you take it, if this is called histogram, okay, so this shows the statistical frequency of the data distribution. If the histogram is skewed, that means it is not occupying the entire range available within the system where the data is being processed. You are going to see the very low contrast image on the screen. If this kind of low contrast image you are seeing on the screen, then their interpretation will be much poor. So what we do, we apply various kind of statistical technique and the and enhancement techniques. An example I showed in the beginning of the deliberation, and that's how you are able to see the much brighter and high contrast image on the screen, where the interpretation is much easier. Okay, when we go to the next stage, that is the image rectification. What we do, because of the various inherent sensor limitation or the data acquisition method, or also because we have to transfer the allied database and we have to overlay the other boundaries on the satellite data. So what we have to do, we have to rectify the image. Now, in the process of image rectification, what we do, we collect the ground control points. Now, the ground control points are the points on the surface and also the corresponding points on the image. Okay, so we try to bring some kind of correspondence. Once we bring a certain kind of correspondence, a pair of coordinates are generated. This pair of coordinates are subject to the some kind of mathematical formulation, and the input data is rectified, and the geo-corrected images are where the images are largely free of any kind of distortion, and they are geo-reference. Once we have done it, we can also transfer the other data which we have collected from the ground or the maps which are already available. That's how the overlay process becomes easier. Now, what the AMRUT document says, it says about the certain standards about the ground control points. No, you have to collect the ground control points using the DGPS, that is Differential Global Positioning System Survey. So this kind of survey, when you are doing it, one has to keep in mind that the accuracy, position accuracy has to be better than 0.5 meter, height accuracy has to be better than 0.5 meter. Okay, and then the GCPs have to be uniformly distributed across the entire image, and at least one GCP every 5 square kilometer. And we have to keep in mind, particularly at the overlap area of the image, a GCP should be collected so that the image stitching becomes better. Okay, that's how the image GCPs have to well distributed on the entire image. Then there's another term called, as I said, that's the ortho rectification, where the three-dimensional correction of the images, particularly in the high and relating area, this has got very, very significant importance, where the GCPs, when they're collected, we should also have got the Z characteristics. Okay, that is the height characteristics. And then after three-dimensional correction of the satellite image, then the ortho-rectified images, they are generated. So there the DEM has got now I'm using a new term called digital elevation model. So this kind of the DEM is generated for ortho-rectification of the satellite images. Next comes once the ortho-rectification has been done, then we have to look for the image enhancement so that we can increase the contrast, and then the image will be much easier to interpret. Okay, so basically the image enhancements are of two types, that is point operation or local operation. Point means pixel based, where each pixel is treated separately. Local operation means based on neighborhood operations, like any kind of filtering technique. So initially, if you remember, know that I tried to demonstrate the example where the images is edge enhanced and the building footprints, they are appear much regular in shape rather than the discontinuity within the pixels. So that's how the image contrast is very, very important. If you look at this image, no, the image is raw in nature. Now it is much difficult to interpret. I hope you'll agree. So what we do, if we apply certain kind of enhancement technique, if you see on the right part where the histogram is shown, so what we do, that because of the very narrow range of the input band histogram, so what we do, we stretch the image and using the linear or non-linear enhancement technique, so that the entire spectrum available radiometric characteristic, they are occupied on the screen. Okay, and that's how the images, they appear much brighter as compared to the raw image. Now this is one example where the linear stretching has been applied. Background, you are seeing the input histogram, and in the foreground, in the different color, you are seeing the output histogram. That's how the images, they appear much brighter, and different kind of linear or non-linear enhancement techniques can be applied. Once the images have been enhanced, then the role of skilled interpreter comes into the picture. Now he can interpret the image using based on physical light table mechanism, or using the on-screen image polygon bonding extraction, line polygon bonding extraction, and that is called photo interpretation. Or one can deploy the machine-based algorithms, and this churns the number, and then the features are automatically extracted based on a priori information or using the post priori information. So that's how the information extraction happens. But again, I'll reiterate here that within the sub-scheme, the emphasis on the photo interpretation because of the intensity of classes which have been prescribed for master plan formulation. So while doing image interpretation, we have to keep several elements of image interpretation in exercise. In mind. Those are tone, color, texture, pattern, location, height, size, shadow association. These all factors one has to keep in mind, and then the skill interpreter, he tries to interpret the information. If you are subjected to the image is subject to the machine-based processing, the one can use the supervised classification technique or the unsupervised classification technique, where within the supervised classification technique, the staining signatures, that means some kind of representative samples are assigned to the computer system based on prior knowledge. Then the images are trained, and then the information is extracted. In the unsupervised classification, then post priori the information is given. But you have to keep in mind another aspect, that is image fusion. Now what the image fusion is and what is the role of image fusion, because what is happening that typically in sensors in general, the panchromatic band, they are much superior in spatial resolution and inferior in spectral resolution. On the contrary, the multispectral image, they are inferior in spatial resolution and much superior in spectral resolution. There are three bands, and then panchromatic is single band. So what we do, that we try to fuse the image. That is what has been being prescribed within the AMRUT scheme for creating the image database. And you are seeing here a panchromatic band which is having the high spatial, because the image extent is same. Panchromatic or multispectral image extent is same, but it is three band, it is a single band, it is high spatial resolution, it is much coarser spatial resolution. They are merged together, and a high spatial and spectral image is generated, which is subjected to the image enhancement and other image-based operation for feature extraction. Once this image database has been created, then one has to generate extract the information, and that information has to come within the GIS. So what is GIS? GIS is a computer-based system that provides capability to georeference the image for the data management, manipulation, and analysis. Why do we bring the data into the GIS? Reason being, there are several layers. I'll come into the subsequent slide. There are several layers which are prescribed for database creation within the AMRUT service scheme. So what we have to do, this all several layers, no, we have to put it together, overlay over each other. Then we have to find out certain characteristics of the inter-image manipulation have to do. Where we can do, we have to do it within the GIS. That's how GIS has got very important role. Now, as I said, the GPS or DGPS, or the recently it is called as Global Navigation Satellite System, because more than one constellation is in the orbit, and we are using the conjugate utilization of several satellites which are from the different constellation. We can get the information much easy and at much rapid pace. That's how it is now called as GNSS. So this has got relevance here for in the AMRUT sub scheme, for the reason being, for the collecting the DGPS point, GCPs, and also for the features data or the point of interest data collection. That's how the GNSS, they have got the important role. Now let us see here kind of database which have to be generated within the AMRUT sub scheme. They are broadly put into 8 categories. These are base layer, then the land use, land cover, building footprints, utilities, hypsography, cadastral layer, and then allied database like the boundaries and hazard prone areas. Totally within the AMRUT sub scheme, as per design standard document, total 69 major classes under these broad 8 categories, and 475 subclasses have to be generated for master plan formulation. So let us take on further what kind of prescription has been made for database collection. Here I like to also mention about one important attribute, that is DM. If you kindly recall, what is the role of DM? Role of DM is for the ortho-rectified database image creation, and also it has also roles subsequently other kind of database preparation. Okay, so this DM, which is not in recent terms, also have come about the digital surface model or the digital terrain model. Okay, so DM is nothing but a digital representation of land surface elevation with reference to any reference datum. Okay, so already if you kindly recall that slide, no, where I said that the cities which are undulating in nature, where the slope is more than 15 degree, one has to use, one has to create the, one has to generate the, use the stereoscopic image, and the DM has to be generated. Okay, so the accuracy of DM as prescribed within the document is 0.5 meter. Okay, so after this DM is generated, then also we have to keep in mind that what are the elements we have to keep in mind, standards we have to keep in mind while doing the on-screen feature extraction. So it is, the document is telling that features which are more than 5 pixel by 5 pixel, okay, because the resolution, spatial resolution prescribed for the AMRUT sub scheme is 0.5 meter, if you kindly recall, then which features which are more than 5 pixel by 5 pixel, they have to be treated like polygon. Features which are less than 5 pixel by 5 pixel, they have to be treated like or the point or line. Roads which are having the width of 7.5 meter and more, that will be treated as polygon, and roads which are narrower than the 7.5 meter, they have to be treated as line. Similarly, there are other standards which have been prescribed for extracting the feature and how they should be categorized under the broad 3 data GIS data formats, that is point, line, and polygons. That's how the features have to be interpreted. They have to be treated as per design standard document. Now, if you recall, no, that the data which has to be collected within the AMRUT sub scheme, they are broadly put into 8 broad categories. So one important category is the base map. Base map refers to a map that depicts the fundamental map elements and which consist of various physical, topological, cultural, or the boundaries. So physical means hills, water bodies, so and so forth. Topological means transport network and so on and so forth. Cultural means parks and gardens. And then comes the boundaries. Let us see a typical base map which has been generated using the satellite data, how it looks like, what it contains. As I said earlier, this which contains under the four basic subgroups. Then comes the land use, land cover. So I hope many of you will be aware about the difference between the land use and land cover. So the land use is characterized by arrangements, activities, and inputs, which is nothing but how a piece of land is being utilized by the people. Oh no, okay, and then that's how the land use is defined. The land cover is a biophysical cover present on the Earth's surface. Now, the land use, they are extracted as polygon, okay, except in certain categories like community toilet, etc., which are fire station, they are treated as points, okay. So there's within the manual, if you go, no, the standard has been prescribed within the land use, residential, industrial, commercial, and other categories, no, the very beautifully the classes, subclasses, and how they should be depicted, and the symbology that has been defined for the land use. Another category is the building footprint. So what within the building footprint, there is some analogy between the land use, land cover, and the building footprints. What its document says that the building footprint should overlap with the urban land use, land cover. That means there is some overlap. I mean, in terms of classes and category for the building footprint, and also for the land use, land cover, because the classes, how they are defined within the land use, land cover, same way the polygons should also depict within the building footprints. And let us see here how the typically the land use, land cover in urban areas, they are extracted. No, if you see, that they are from different parts of the country. The how the urban areas and different classes they appear. So if it is the commercial, industrial, transportation, institutional, residential, okay, that's how the different kind of or auditorium, how they appear on the screen. Let us see here. Commercial, because of the array of activities, you see here, the because of the mobility and because of the kind of commercial setup, they are I mean, how its manifestation appears on the ground. If it is industrial area, you're going to see the some kind of effluent, or you are going to see the shed, industrial sheds, or other some kind of fumes, or any kind of other activity on the part of the image. That's how we classify, interpret the part of the image within the industrial area. Similarly, other based on the elements of image interpretation and large contribution from the ground, that's how the land use and the cover present on the earth surface together, called as urban land use, land cover, they are interpreted, okay. And then other characteristic of the urban area, they are density. See how the image speaks of the urban areas. If you top two images you are looking at, you are seeing the density of the urban setup. This is much sparse on the top image as compared to the bottom two, okay. And also what you are looking at top two images, that there is a very distinct and spatial pattern of houses and the transport on the top two images as compared to the bottom two images. That's how the that happens. Another, after the information extraction is has been done, the data has been collected, the data has been analyzed, and then the data has been topological is in terms of connectivity. Temporal means if you are in overlaying the images or the interpret maps one over another, how the polygons they are fitting one over another. So it's how the four kind of accuracy component is important. Now, in terms of positional accuracy, that is planimetric accuracy, as per the standard definition, for any given scale, so accuracy has to be 0.25 millimeters. So as per because within the AMRUT scheme, it is prescribed that database has to be generated at 1:4,000 scale. That means the 1 meter accuracy has to be met. So in terms of thematic accuracy, again one has to look into the thematic characteristics of the classes, so that the classes they are not misinterpreted. In terms of now what the document prescribes, that the accuracy has to be checked internally or by the external agencies. If it is internally, the 100% quality check has to be performed. If it is external, that means 15% of the randomly selected polygons or the sample have to be collected and they have to be taken care. Now, once the database is generated, the document says the various properties of the GIS, that is completeness, correctness, conformity, then consistency and GIS compatibility has to be met. So what is this completeness? That means no gaps. Corrected means correct interpretation. Conformity means you should conform to the standards. That means because of the nomenclature for each class and each category has been given, okay, codes have been given, so that kind of code has to be met for entire for all 497 or 500 cities. They have to be met. Consistency means suppose one interpreter is classifying or interpreting a part of the image under the commercial area, so same kind of class has to be there for the similar kind of image manifestation other image. So this kind of consistency has to be there. Compatibility means the GIS has to be compatible to the image. So let's see how the accuracy is being assessed. So basically the accuracy, after the image has been interpreted, then image has been corrected, then one has to check the accuracy. The accuracy will be of two types: producer accuracy or user accuracy. So let us take some example. This is the kind of confusion matrix which is generated, and then accuracy has to be found out using the diagonal elements. That is overall accuracy. Then the producer accuracy will be based on the within the diagonal element. The commercial, if it is a 69 polygons, they are correctly interpreted, and the total 75 polygons are there. The 65 upon 75, that is 87% for a given area. That's how the accuracy has to be defined. In terms of topological accuracy, as I said, all the polygons, all the points, they should conform to the GIS. Okay. So as I said, the other layers which have to be taken into account within the AMRUT sub-scheme, they are cadastral, boundaries, and hazard-prone areas. What the document prescribes, that these all ancillary database have to be collected, they have to be rectified, and finally they have to be brought into the GIS. Why so? Because the master plan formulation is not only based on land use, land cover, or based on building footprint. This has to be done in accordance with the Act, Town Country Planning Act, and also any kind of sprawl. If this has to happen, then this should be hazard-free area, and then it should be regulated as per the law of the land. That's how the other layers have to be also brought into the here. Another important segment what the AMRUT sub-scheme prescribes, that is utility management. Now, typically what is happening, you may be aware that within the urban areas, typically the utilities, the database, either it is available in individuals, engineer's mind, there will be paper map, there will be memory based, or there will be CAD files or other thing. Okay, so what we have to do, with this endeavor, all this AMRUT sub-scheme endeavor, entire this kind of database has to be digitalized. They have to come in a single platform. That's how all these kind of methods have to be followed, so that existing utility records, they have to be digitalized. So AMRUT's document says that all utility layers like water supply, drainage network, sewerage, etc., they have to be brought into the GIS domain. Okay, after digitization, and the standard schema for different kind of utility network, they have been defined. They have to be collected using the various ground-based methods or allied techniques, and then they have to brought into the GIS domain. Okay, whether it is water supply network, storm water network, sewerage network, power and gas network, and so on. So one can also utilize the mobile apps, and then from the mobile apps, this all database mobile apps has to be generated. And here I like to mention that IIRS has generated, it has prepared one mobile app that is called Sankalan. Okay, so where the Sankalan mobile app can be used for one can go to the ground. Data. This Sankalan mobile app is available on the IIRS website, and then one can install on its own mobile, and then one can collect the data using this Sankalan mobile app. Okay, so this mobile app has got wide usage. What the document, AMRUT document says that one has to follow the unique methodology for finding out the service level improvement gap for creating the new facility. And that will be, first of all, assessing the service level gap, how to bridge the gap. While doing so, one has to examine the alternatives, whether the plan A is useful or the plan B is useful. If plan A is useful, what is the cost? Plan B is useful, what is the cost? And this kind of techno-feasibility, techno-economic feasibility has to be done. And while doing so, then one has to also think about the out-of-box thinking. Okay, so while the utility database has to be created, we are aware that for several parts of our country within the urban areas, utilities are underground, below the surface, and then the formation is largely remains the ground engineers, the field engineers' mind. So how to collect and estimate all this information within the GIS, where the ground penetrating radar is GPR is one such instrument which is highly beneficial, and where with the GPR traverse one can find out the depth of the utility, one can find out the position of the utility, one can find out the diameter of the pipe. This kind of non-invasive technique can be deployed for finding out the utility's location, depth, etc. Okay, so if this utility database has been found out, then, for example, if it is the water utility, what can one can do that. Typically, any water utility data enhancement, infrastructure enhancement happens based on the thumb rule based methods. For example, as per the CPHEO guidelines, whether it is 135 LPCD or 150 LPCD multiplied what population the total by the facilities demand is calculated, and how the facilities augmentation happens. But this does not take into account the hydraulic properties of the gradient, etc. So one can deploy what one can do, because the utilities database has been created. Okay, and then one can also use the digital elevation model. One can use the building footprints which are already generated within the AMRUT sub-scheme, and then one can find out that it might be happening because of the terrain undulation, because the water flow is through the gravity. So because of the undulating terrain, though with the thumb rule method, the gross estimation of water demand has been done, but even the water is not reaching at the downstream level. That's how one can use the hydraulic methods, and these hydraulic methods and this which are also coupled with the GIS software, and there are plenty of software available where the pipe database, the water utilities database, What one can do, one can collect the stormwater drainage network database, put in the GIS, and then there are several software which are working in tandem with the GIS software, and one can do the modeling whether existing drainage infrastructure is sufficient or there are inferior. If so, and based on the hazard intensity and the vulnerability characteristic, which part of the urban area they are likely to face what kind of urban flood hazard, that kind of modeling can be also be done. So these are the some over 1 hour session. No, I tried to my endeavor has been to give the glimpse of the geospatial technology. While doing so, I've also tried to link it with the various design and standards component which have been defined under the sub scheme. Okay, so all these while doing so, no, because still we feel that within the urban planning segment, still this exposure is required for the urban planners to how to use the technology. So the IIRS has teamed up with the Town and Country Planning Organization of the MOHUA, and we have developed the course content jointly for the 3 days program, for the 2 weeks, for the 4 weeks, depending on the level of urban planners, and then tier 1, tier 2, tier 3 program for the decision makers, for the middle level officials, and for the junior level officials we have done. Okay, and then countrywide training program has been conducted by at Dehradun by IIRS and several other agencies within the country. And then capacity building and training has been done. Okay, so this kind of endeavor has also been planned under the sub scheme. So with this background, I end my deliberation. I'm thankful to you all for attending this, and then I shall be happy to give the answer to your queries. I hope there will be several queries, and then shall be happy to give the answer to you. Thank you very much. Okay.